Hello students, let's go ahead and talk about how to write an equation using a point and x-intercepts. So a meteorologist creates a parabola to predict the temperature tomorrow, where x is the number of hours after midnight and y is the temperature in degrees Celsius. Now the first thing I notice about this question is that I have an intercept here and an intercept here, and then I also have a point. So that means that I want to use intercept form, which is y equals a, x minus r1, x minus r2. So looking at my graph, I say this is my point, so this is going to be x, this is going to be y, 4 is r1, and then 24 is r2. So we would say y is 9.6 is equal to, a is the variable that we're trying to solve for, x is 0 minus 4, and then again x is 0 minus 24. So simplifying, 9.6 equals a times negative 4 times negative 24, or 96a. Now this one works out very nicely because if we divide by 96, we get a is equal to 0.1. So that means that our function is y is equal to 0.1 x minus 4 x minus 24. Now the next question is, we'll first write a function. We did that. What is the coldest temperature? So the coldest temperature is going to be around here at the vertex. So if you remember, in order to find the vertex in intercept form, first I need to find the axis of symmetry. The axis of symmetry is going to be located directly in between the two roots, which are 4 and 24. So the way I can find the midpoint between them is just to average them. So I would just say 4 plus 24 divided by 2. It's 28 divided by 2, which is 14. So that means right here at 14 is where the vertex is. Now in order to find the vertex, I find the value of y at 14. So I'd get y equals 0.1 times 14 minus 4 times 14 minus 24. So that would be 0.1 times 10 times negative 10, which would be 0.1 times negative 100, which turns into negative 10. So that means that the coldest temperature is at 14 hours and it's negative 10 degrees. Word problem, we answer in words. The coldest temperature is negative 10 degrees, which is reached after 14 hours. Okay, now I'm going to label that point right there. This is 14, negative 10. Now the next question is, what is the average rate of change in temperature over the interval in which the temperature is decreasing, increasing? Compare the average rates of change. So this question right here, I'm going to zoom in a little bit, and I'm going to clean this up so we can see what's going on. Everything to the left of the vertex is where it's decreasing, and I want to find the average rate of change between those 2 points. That's actually a very simple procedure, because in order to find the average rate of change, I'm just going to draw a straight line as if it always changed the same amount. The rate of change between those 2 points would just be the slope. And then again, to find the average rate of increase, I would just find the slope between these 2 points. So I'm just going to move off to the side here. Quick reminder, the equation for slope is y number 2 minus y number 1 over x number 2 minus x number 1. So for the decreasing temperature, I would say this is x1, y1, this is x2, y2. So that would be 9.6 minus -10 divided by 0 minus 14. Now actually I did that backwards. I did y1 minus y2, and that's okay as long as you do x1 minus x2. So you just have to stay consistent. So 9.6 minus -10, that would be 19.6 divided by -14. And I'll go ahead and use a calculator for that. 19.6 divided by -14 is equal to -1.4. Now if we do the same process for where it is increasing, oops, 1410, I'm going to say that this is x1, y1, and this is x2, y2. So that means we would do 0 minus -10 divided by 24 minus 14. So that would be positive 10 divided by positive 10, nice easy division, 1. So when it's decreasing, it's changing at a rate, an average rate of -1.4 degrees per hour. When it's increasing, it's changing at a rate of +1 per hour.